So there's something else that we can use with intersecting chords. Whenever you have intersecting chords, there are special ratios that exist within the segment lengths. So when I see these chords, I'm gonna create some segments here that I'll just put in dotted. That one really looks terrible. Let's try that again. Still not great. So anyway, now hopefully you see that I have two triangles here. So I have this little triangle on the right and this larger triangle on the left. Again, I have vertical angles, so I know that that pair of angles is congruent. Let's look next at these two angles at the bottom of the circle. So if I follow this angle that has this solid segment and this dotted segment, if I follow that out, I can see that this is the arc it is intercepting. This angle, if I do the same thing, this other intercepted inscribed angle, if I follow those rays or segments out, it intercepts the exact same arc as this angle. So because these inscribed angles are intercepting the same arc, I know that they have to be congruent to each other. So now looking at these two triangles, I have angle, 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 which means that they are similar triangles. In similar triangles, we know that we can set up proportions to find missing side lengths. So let's say that I know some of these segment lengths. So in this larger triangle, I know that this segment has a length of 15, and this segment has a length of 9, and the smaller triangle, I'm given two lengths, 5 and 3. Now, because these are similar triangles, I know that I can set up proportions to show their similarity. So 15, this side here corresponds with 5. I can tell because of the angles that they're in between. So 15 over 5 should be equal to this other pair of corresponding sides, which is 9 over 3. 15 divided by 5 I know is 3, and 9 divided by 3 is also 3. But let's pretend that I didn't actually know this segment over here. I can determine it by setting up proportions. So 15 over 5 equals 9 over x. When I cross multiply, I'm doing 15 times x equals 5 times 9. Now notice where these pieces come from. 15 and x come from the same chord. So I'm multiplying together the two pieces of this chord. And then 5 and 9 come from the other chord of this circle, 5 times 9. So this is how you'll usually see the formula stated or set up for finding missing side lengths when I have intersecting chords. You'll usually see it as this first piece times this second piece is equal to this third piece times this fourth piece. Again, I'm just multiplying together the pieces that are from the same chord. So if I'm looking for a more general formula, here I've placed, instead of using actual numbers, I have these two intersecting chords and I'm using 4 variables to represent those 4 pieces. So if I imagine that intersection point is cutting each chord in half, this chord is split into A and C, this chord is split into B and D. So the general formula here would be A times C equals B times D.